Very good. So this is going to be graphing Limacons, and we're going to use that property of symmetry to help us graph Limacons with a little bit less work. We're going to have to find less ordered pairs manually. So in general right here, this is the same graphing that we've done before. But before we go ahead and graph these polar equations, we're going to go ahead and prove symmetry, right? And then we're going to talk about how we can use symmetry to help us evaluate less ordered pairs. So I'm going to start with the second one because this one has a symmetry that's a little bit more complicated. In general right here, I can see that with my second equation, I've got r equals 4 plus 3 sine theta, and with sine, I can think that I probably am going to have symmetry with respect to the y-axis. Now, when we have symmetry with respect to the y-axis, that basically says that if there is an ordered pair r theta on our graph, then we're going to have the corresponding ordered pair that will be r pi minus theta, right? And again, what we're trying to show with symmetry is whether we plug in theta or pi minus theta, we're basically going to get the same equation in both cases defining our r, right? So right here, I'm going to go ahead and plug in that pi minus theta into my equation. And right here, I will have 4 plus, and then I will have 3 sine of pi minus theta. And right here I can say I'm going to have 4 plus 3, and with the difference identity for sine, we have sine pi cosine theta, and then minus cosine pi sine theta. Now right here we know that sine of pi is going to be 0, so we've got 0 times cosine theta, and we know that cosine of pi is going to be -1, so we've got a -1 sine theta. And now basically what we're going to see here is this term is going to go away, and we will get a positive sine, which gives us 4 plus 3 sine theta, which is the equation that defines our r. So right here we've just proven symmetry with respect to the y-axis. And what that's going to mean is that I only have to identify ordered pairs on one side of the y-axis, right? Now this is going to be a little bit weird, and we're going to set it up a little bit differently when we are finding ordered pairs for functions that are symmetric with respect to the x-axis. But right here, when we're finding ordered pairs that are going to be symmetric with respect to the y-axis, we basically want to think we're going to start down here at -pi/2, and then right here I'm going to go up and find an ordered pair at -pi/4, 0, and then right here that's 0. And then we would say pi/4, and I'm also going to find an ordered pair at pi/2, right? And those are ordered pairs that are basically going to be on the right side of the y-axis. And now once I've got those ordered pairs, I can reflect them across the y-axis and graph my limacon. So right here, when we type this into the calculator, we are going to get the ordered pair -pi/2, 1. We're going to get the ordered pair -pi/4, 1.9. The ordered pair 0, 4. The ordered pair pi/4, 6.1. And the ordered pair pi/2, 7. So I'm going to go ahead and graph these guys. And my graph is going to look a little something like this. So right here at my -pi/2, I've got 1. And then I can say at -pi/4, that's over here, I've got something very close to 2. We'll call it 1.9, just a little bit less than 2 right there. At a rotation of 0, I've got 4. At a rotation of pi/4, I've got 6.1, so just a little bit past 6. at a rotation of pi over 2, I've got 7. And now I can sort of see that I've got half of my lemicon here, and what I'm going to do is I'm going to reflect the ordered pairs on the right side of my y-axis across and draw the entire lemicon. So right here, where we'll say we have this ordered pair reflecting to approximately this ordered pair. We've got our ordered pair on the x-axis at 4, reflecting across to the negative x-axis at negative 4. We've got our ordered pair right here at pi over 4, 6.1, reflecting across to this ordered pair right here. And we don't really need to reflect the ordered pairs that are on the y-axis, right? So at this point, we'll go ahead and get our graph, and I'm just basically going to trace along connecting the ordered pairs I've got as I rotate around. And this right here would be the graph of our lemicon. And again, you can type this into the calculator and check it out. This is the graph of our lemicon symmetric with respect to the y-axis, and of course sine is what's cluing us in to the fact that we would be symmetric with respect to the y-axis. With this graph, we are going to think that we're probably going to be symmetric with respect to the x-axis because we're looking at a cosine lemicon. But of course we're going to need to show that too. And what that's going to mean is showing that an equation that has the ordered pair r theta is also going to have the ordered pair r negative theta. And right here, what I want you guys to do is to go ahead and evaluate the symmetry of cosine, basically test for that symmetry with respect to the x-axis by plugging in that negative theta and showing that we're going to get the same equation back. And once we've got that, we'll talk about the rotation values we're going to plug in to get ordered pairs for our polar equation. So why don't you guys pause the video here, and we'll come back and look at this in a second. All right, guys, so right here we have our polar equation with the negative theta plugged in. And what we can see here is that because cosine is an even function, when we evaluate cosine of a negative theta, it's the same as evaluating cosine of positive theta. So we can say our 2 plus 2 cosine of negative theta is going to equal 2 plus 2 cosine of positive theta, which is the equation that defines r. And that shows that we are symmetric with respect to the x-axis. Now, since we're symmetric with respect to the x-axis, I really only need to get ordered pairs on one side of the x-axis, and then I can reflect those ordered pairs across the x-axis and draw my lemicon from there. So right here, what I've done is I've got some rotations here that will basically take me across the top of the x-axis, right, from 0 to pi, right? And what I'm going to do is I'm going to evaluate these rotations, and they're going to be rotations of 0, pi over 4, pi over 2, 3/4 pi, and pi. And once we've evaluated those rotations, right, we're going to have a collection of ordered pairs on the top of the x-axis that we can then reflect across the x-axis and get ordered pairs that will help us draw our lemicon. So right here, what I want you guys to do is to go ahead and find the ordered pairs for the rotations we've got right here, and then plot those ordered pairs on the top of the x-axis, then reflect them across the x-axis, and draw your lemicon, and we will come back and look at this in a second. All right, guys, so we've got our ordered pairs on the top of the x-axis here. I plotted out those ordered pairs, and then I reflected them across to the bottom of the x-axis, right? And now we can sort of sketch that lemicon, right? So right here we've got our first ordered pair 0, 0, and as we rotate around, we hit that 0.6, and then we have the r value of 2 for rotation of pi over 2, and then we go all the way out to an r value of 3.4 for rotation of 3/4 pi, and we're down all the way out to 4 for rotation of pi, and then right here I'm going to go ahead and continue to rotate around, hitting all of those points that I reflected across. And there's my lemicon. And then, you know, one of the things we can sort of reflect on is that we're seeing the same lemicons we would expect to see in terms of the orientation as we laid out in that previous page, right? With regards to how they're orientated horizontally or vertically, and where that largest R value is extending to on the positive or negative X and Y axis.